Smithsonian. And Lucile is going to share a little bit about her background and take us on a journey of her work. So, Lucile, thank you so very much. You were so enthusiastic in your response, and we are really looking forward to your presentation this evening.
Thank you. I'm delighted to be here and to have met the Botanical Society. I'm just looking to sharing my screen.
And Lucile and Carl, it's very exciting. You know, next year we are 125 years in existence. So, yeah, very, very cool.
Can you see correctly my screen?
We can see your screen, but we're also seeing all the slides on the side. So maybe you can go to slideshow, full screen.
Okay. Is this correct?
It says to double click to enter full screen mode. Okay, so there we go. Let's see.
Okay. Okay.
Next, a little slow.
Okay.
Yep,
We're
perfect.
good? Yep,
Yep,
great.
we are good. Yeah, wonderful.
So yes, I'm Lucile Joursain. I'm currently a Peter Buck Postdoctoral Fellow at the Natural Museum of Natural History here in DC. I just began on the 15th of September. And I am currently working on a Malagasy genus called Gruya. But what I'm going to talk about now is another genus. So what I've been doing for the last 5 years. I did my PhD. I've worked at the National History Museum of Paris and at the Botanical Garden of Metz, which is in Belgium. And I did morphometrics and phylogenomics serving Malagasy biodiversity to work on the systematics of Dombeya section Dombeya from the Malvaceae family. So you might know the Malvaceae as the baobab. You might know the mallows, maybe the cocoa, Theobroma, or even the cotton flower, Gossypium. But I guess you do not know Dombeya. It's a genus we can find in Africa, Madagascar, and the mascarines. So the mascarines are in the Indian Ocean. We have Reunion Island, Mauritius, and Rodrigue. We also can find Dombeya in the Comoros Islands. And in the scattered island, we have a little island called Juan de Nova. Dombeya can be bushy, it can be a tree. It can have bisexual flowers or unisexual flowers, as you can see the different floral parts. It can be pollinated by lizards, like a Philzuma here from Reunion, or different insects, like we see here, a little bee. Specificity of Dombeya is we often see what's called heterophilia. It's different of leaf morphs. We can see on the left an old tree leaf with an entire margin, and on the right we can see a young tree leaf with a palmatifid shape. So in Africa, we have 19 species, but the maximum of the diversity is found in Madagascar, where we're going to find around 150 species. We'll find 14 species in the mascarenes, all very pretty. We can have a high morphological diversity in this genus, but especially in Madagascar. It has a very complex taxonomy, and the genus is thought to have emerged around 5 million years ago. So it's early. So we can say it's had a radiation in Madagascar, and it's a great genus for the study of evolutive process. So what we usually do to work on such large genuses is we select a specific section, small section, that seem monophyletic. As was done on the subsection Macrontae, which is now a new genus, Andranghitra. Or what was done was also working on a geographic region like the Mascarenes by Le Péchon, or another section, Hilsenbergia, with its very particular corimbos cymes. So what I did was I was focused on a section Dombeya. It is an autonomous section, so it bears the type of the genus. It has the same distribution as the genus, and it has a very distinctive biparous cyme with scorpioid terminal units. As we know, the species concept is polysemy. It's a well-known issue in biology. There are tons of definition. So I just wanted to be clear on what I was using is the smallest unit supporting a unique combination of characters. I'm going to do a brief history of the section. So it was described by Planchon based on the type of the species Dombeya acutangula. Later, Oschritiner created a superfluous name, Capricornua. Later, Arends worked on Malagasy Dombeya. He wrote a huge book on a huge flora that is still in use, and he defined two subsections separating the tricarpellate species. We have only one tricarpellate species, which is different from all the other pentacarpellate species. The last work until now was by Siani, and he did a huge lumping. The entire section would only be one species. We would have only two species in Africa. We had to choose a new holotype for Dombeya leucorea. We also have Dombeya cincinata, very, very similar. We have one species in the mascarene, which is separated in two subspecies. Dombeya acutangula subspecies acutangula and Dombeya acutangula subspecies rosea. They have a different color in the petals, as you can see. In the subspecies, the white one, Dombeya acutangula subspecies acutangula, we have two varieties differentiated by the heterophilia morph, so the young leaves morphs. We have the variety actangula with an entire margin, and the other one with palmate leaves. About the Malagasy species, we have 9 of them and 2 varieties. The first one would be different by the length of his style, which should be short. Also Dombeya boraginopsis. The famous tricarpellate species is quite well differentiated. Another supposed species would be Dombeya urinoides, with its strange shape of leaves. Another is Dombeya triumphatifolia, which has weird echinate hairs. Dombeya quincecostata, only known by its type, a single specimen, not in very good state, and Dombeya rubifolia. The traits used to differentiate the species are not very reliable, not very usable, as often you would say. I pointed out an example to differentiate 2 species, and it would say that the staminod are spatulate, nearly longer than the stamens on one side, and on the other side, the staminodes would be sublinear and significantly longer than the stamens. But in reality, it's very hard to choose between the nearly longer or significantly longer. So the first way to test all those species hypotheses is a classic morphological approach. The second one is morphometrics, and the last one will be genomics, phylogenomics. We could use lots of specimens from Paris, Mass Botanical Garden, and all the scans. Also, I was able to go to Reunion Island, so I could collect specimens, and I was able to see the living collections of maize from Madagascar, Malagasy living collections. Let's see some interesting traits. About the hairs, we often say that the hairs of Dombeya, but more widely of Malvaceae, are stellate, but it should be called actually a tuft because of this specific shape. And the density is very variable on the organs. Here you can see the stipules of the different species we saw. And I want to point out the stipule of Dombeya cincinata. It has a very weird stipules compared to the others. And also on Dombeya acutangula, we have a glabrous area on the addaxial surface. Correct me if I'm wrong. But that's the only species with this glabrous face. You remember Dombeya urinoides with its weird shape leaves? Well, I saw them on the specimens growing from seeds that were collected on Malagasy Dombeya griviana. So we know it's only, again, a use shape, and it should not be defined as a species. Also, in the collections, we saw specimens from Juan de Nova in the Scattered Island, and they have very weird leaves compared to Malagasy and African ones. Here is the floral diagram of all the species. We have 5 sepals, 5 petals. They're dially petals. We have 5 staminodes and a crown of 15 stamens total. The gynosium is superior, and we have 3 or 5 fused carpels with 3 or 5 cavities. The placentation is axile. Here are the epicalyct bracts. It's very commonly used to differentiate Dombeyas. And the size of Dombeya acutangula is very different from all the other. About the sepals, they are curved, which is absolutely stunning. And we have reflexed sepals. Here you can see the staminodes and stamens on the staminal crown. Also, the ovary is very hairy. We have a long style and 3 or 5 stigmatic branches. So, what can we say about this morphological study? Well, we have to add a new column in our table because of the potential taxa from Juan de Nova, which has a particular morphology. We also can differentiate Dombeya cincinata, the African species, from its steeple that are different from the others. The mascarine species and subspecies, or this species, sorry, is different from the others by its specific stipules and apical bracts, but also we can differentiate both subspecies. One of them had pink, petals, and the other has whites. Dombeya borraginea is the only species with 3 carpels. About the others, well, maybe we only have 1 species. We have to test. Now with morphometrics. Lots of measures. Fortunately, each geographic area was represented. We have obviously unrepresented taxa, but the main cause is the lack of material. We used 15 variables, 11 continuous characters, and 4 discrete ones. Here's an example of the measured tags. So I used 3 organs for each flower. For example, 3 staminodes or 3 stamens. And also, I measured the staminal column in 3 different points because it was variable. The factorial analysis on those mixed data said that the AX1 was explained by the length of the sepal and the width of the petal. The second axe was itself explained by the length and width of the ovary. So on A, we have specimens with big ovaries and short sepals. On B, we have small ovaries and long sepals. What we can say first from the student test is that Madagascar has significantly different measures from Africa and from Reunion and from Mauritius. Each geographic area is significantly different from each other. The Rodrigue specimen is graphically very distinct on both axes. The specimen from Juan de Nova is graphically located between African specimens and Malagasy ones. But unfortunately, inside Madagascar, we cannot differentiate any species because all of the Malagasy species are found in the graphic space of the largest species, Dombeya greviana. I tested if we had two varieties of the largest species, Dombeya greviana. We should have, it was about the length and width, and we did not, because we did not have a bimodal distribution. It was Gaussian curve, so no, we only have one species. So the morphometrics told us that yes, the taxa from Rodrigue Island is distinct from the others. The African species are different. Each the species from the mascarene also, it's different from each other, and they are differentiated one from the other. But as we saw, the taxa from Juan de Nova is not very distinct, and in Madagascar we cannot differentiate species. Now, phylogenomics. The objective of the genetic sampling was to represent each taxa of the section and each geographical area, but also to get several specimens from each known clade of the large genus Dombeya. We got 64 specimens and 30 taxa in total. Several taxa missing, unfortunately. Here is the main result, but let's just look at what we have. The first result is that it's not monophyletic. We have the African species not inside the clade. So the African species has, yes, apomorphic stipules, but we would have to dig in further. About Dombeya greviana, it is distributed in all the dry areas of Madagascar. Its bracts are elliptical with a sharp, non-acuminate apex, and it has linear stipules. The genetic results show that Dombeya rubifolia is actually a heterophilous morph, and the species Dombeya boraginopsis is polyphyletic, so it is not justified as a species. We also were able to find a clade from Boini region. It's a savanna climate with dry winters and wet summers. What's specific about those specimens are the bracteoles, epicalyx bracts, with an irregular margin and an apex really acuminate. Next, we have the Dombeya mariveronensis. This taxa should always have a short style, but we saw that the length of the style is very fluid characters. Also, it's only represented by one population, so we decided that the specific level is not valid for this taxa. Next, about Dombeya boraginea, it has a very, very similar morphology. On the nuclear genome, those specimens are monophyletic, but they are not on the chloroplast. Actually, we have on the left the chloroplast cladogram and on the right the nuclear ones. And in red, we have the Dombeya boraginea. And it's not a single thing. We have lots of clades that are incongruent between the two cladograms. It's a common issue, and it is explained by the fact that chloroplasts are transmitted by only the mother. It tends to give geographic clusters, and the nuclear genome is transmitted by both parents, so it often leads to morphological groups. So what we have here is introgression or hybridation. Well, we'll have to dig into that more thoroughly. The taxa from Juan de Nova is genetically very close to Dombeya acutangula from the mascarines, and its phylogenetic position is quite consistent with its morphology. The mascarine species is monophyletic, with the stipules and bracteole as a strong synapomorphy. Also, the two subspecies are geographically and genetically corroborated. The Mauritian and Rodrigan specimens seem closer from each other than the Reunionese specimens. And we could argue that the Rodrigan specimens could be a new intraspecific taxa. Here is now our table with the genomics results. So yes, for the African specimens, yes, for the masculine taxa, yes, for the Dombeya borraginea, the tricarpellate species, but only based on the nuclear. We cannot say for several Malagasy species because it could not be sampled. And we have a very well differentiated taxa from Rondenova. To conclude, apparently my section is not monophyletic, so the bipolar sign with sculptured terminal units seems to be a convergence. We have to redefine the Dombeya section based on the Malagasy and Mascarin specimens and reinvest the Capricornia section from Aran for the African specimens, which is quite apomorphic. It has apomorphic traits. And we have many synonyms for Dombeya greviana. As a perspective, I would like to date this phylogenetic tree with primary calibration and secondary ones. And if possible, infer ancestral areas to do a biogeographic study. Well, thank you a lot, and very happy to be here.
Lucile, thank you so very much. It's very clear that you have spent years studying this. And yeah, this is a wonderful time to, I hope you're seeing lots of applause going on here. And yeah, this is a time to open it up to questions and inquiries and observations. So I'm just going to open the floor here.
I have a question about the floral scent. I remember when I was at the University of Florida, there was, I believe it was a Dombeya on campus, and the flowers smelled like cake batter. Is that a common?
What did you say? It smelled like
cake batter? Like
oh.
you know
In the mascarines, they really had a honey-like smell.
Okay.
So, yeah.
But yeah, it was one of the most unique floral smells I've ever experienced. So, but I enjoyed your talk very much. Thank you.
Thank you.
Lucile, Ken here. I have a question. What happened to the 3 carpellate taxon among most of your 5 carpellate? I've sort of lost track of how that relates to them. Is it it's not basal? Is it embedded in them, or where does it stand?
Oh, it's this species is on. Can you see my my screen still?
Yep.
Yeah. Yeah.
There you go.
Yeah. This is a tricarpellate species.
Oh,
so
okay.
It's on the chloroplast, it fell on 2 different clades, and on the nuclear, it's very good. So there's obviously events of introgression maybe ILS, incomplete lineage sorting, that I have to deal with, because I really feel like it's the only species that has three carpels. So it's a strong character. So it has to be monophyletic.
And everything around it is 5 carpellate. All those.
Yeah, everything. Yeah.
Somehow it's lost some carpels along the way.
Or did it lose them? I have a question about the history of the mascarenes. What is the age of the mascarenes? What is their origin?
2 of them are from the Reunion hot point, but Rodrigue is not. I'm trying to go back to the.
I'm thinking about geology.
Yeah, it's not an old island. I think it's around 3 or 5 million years for the Reunion. Mauritius is older, and Rodrigue is a bit older, but it is not from the same hot point. I think it's 9 million years ago for Rodrigue. But the volcano from Reunion is still active. I don't remember its name. It's quite well known, but yeah, it's still active.
Yeah, a question for you. Question. Steve Lonker here. So I had the pleasure several years ago being in the Kew Gardens Temperate House and seeing Dombeya Mauritania, one of the specimens taken from the 2 clones, and it just blew me away. And speaking of critically endangered plants, how does your work affect the IUCN red listing of plants like Dombeya acutangula, found in Mauritius and Reunion, and other species that are critically endangered or threatened?
I think the mascarene species were quite well known, well studied. So the 2 subspecies and varieties that exist in Reunion Island are well protected. I even saw plants planted by I don't know which authority, but it was obviously a government policy to plant, like in the airport, in different parks, Dombeya acutangulas, because it was, it was well worked on. If we decide to describe a variety on Rodrigue, that would maybe I don't know if it would change things, because Rodrigue Island is very, very small, very threatened. There are like 9 specimens on this island. It's critical. And I don't know if describing a specimen, a variety, would change or strengthen policies. I really don't know, but they're quite well protected, I think, in these areas.
I have a question. My name is Jill, not Warren. That's Warren. I was just curious why, if you have some comment on why there's Dombeya is so common on Madagascar.
Diversity.
Yeah, I'm sorry, diverse. It's and there are more species there, right? There are like 150 or something.
Yeah.
Okay, thank you.
Yeah, 100 to 150 species. Yeah. I went to Reunion Island because of the pandemic. It was very complicated to go to Madagascar at this period, but the work on Dombeya has to be done in Madagascar, obviously. Yeah.
But I was curious why there's so many species on Madagascar. Are they?
Oh,
Yeah,
they emerged there.
that's their origin.
Yeah, around 5 million years ago. They are endemic, yes, from Madagascar.
Okay, thank you.
What is the sister group to Dombeya, and where is that located?
It's in the Dombeyoidae subfamily in Malvaceae. In Well, it's up to discussion which genus exactly is sister to Dombeya. It's in discussion. The Dombeyoidae subfamily is absolutely in discussion, but I would say we have. We have an Asian clade, which is sister to all those Malagasy endemic species. There are also numerous genuses in the mascarines. But if you can see the figure, there is a red point, a red circle, and the true Dombeyas are on the top of this point, and under you have mascarine genuses / species, and under before this point we have all the Asian clade.
Yeah.
What is your plan to work on at the Smithsonian?
I currently work on Gruya, the genus Gruya in Gruyoidae subfamily, especially on Malagasy Gruya. My project is to do a biogeographical study of the genus inside the subfamily. I would like to have the diversity of the subfamily to understand how Gruya evolved, how many times it went to Madagascar, because it didn't seem to have emerged there. Yeah, this is my Malvaceae second project.
So did the Madagascar group give rise as India rafted north? Did that introduce things to Asia and then they spread back to Africa? What's going on there?
About Gruya?
But in general with the Malvaceae.
Oh well, lots of movement apparently. In the Dombeyoidae are only paleotropical, but in the Grivioidae we have a neotropical clade. No, it's not monophyletic. So yeah, we have species in the neotropics in Grivioidae.
Okay, well, I look forward to more work on that.
Yeah.
Hope to see you at the museum again one day.
One day.
Soon.
A very nice talk. Thank you.
Yeah, I think
thank
you.
we have a minute or two for one or two more questions.
Ken here, I'll ask one more question. What about your Wanda Nova weird thing? Is that taxonomically worth recognizing at some level?
Yeah, I think it is. Because I didn't exactly expect the Juan de Nova specimens to fall in a clade very near to the mascarene species. Well, there's a whole continent between them. I think it's worse. It's worse. Yeah. And also the leaves are different. The morphometrics said it's between Madagascar and Africa, so it's very funny. Yeah, it is. It's exactly where it's supposed to be. But it's also a very small island, so it's I found it very difficult to draw the line when there are so few specimens.
Lucile, I want to thank you, and I want to share some of the things people are posting in the chat. And so I couldn't agree more with Marion. Thank you for such a lovely talk. And Anne says, you have such a great way of explaining things so clearly. And bravo, what a beautiful presentation. Thank you everybody for your questions. Lucile, thank you again for joining us this evening. And just a reminder, we look forward to seeing everybody in person in December. And Lucile, we look forward to meeting you in person. And you'll see information coming out about December, but that is our time to get together for our holiday celebration with a wicked potluck. And Carl, I just want to say, I am so looking forward to working with you and Greg, likewise, as we make the transition here. So everybody have a wonderful evening. Keep your eyes out in the sky. Tomorrow is the beaver moon, called the beaver moon, because in 1933, the almanac started naming moons. And apparently it's called the beaver moon because it's when beavers would go into their den, but also when indigenous people would actually hunt the beaver for their very warm pelts. So it's a beautiful sky tonight. So if you have a chance, go out and look at this beautiful moon, which will be full tomorrow night. So Lucile, thank you so much for being with us tonight.
Thank you. It was
Thank
lovely.
you.
Thank you, everyone.
Good night.
Good night.